Okay, today's video is going to be about the special relationships in a circle, including the radius and tangent. And then it's also going to talk about the relationships that an inscribed or central angle have. So to start, we're going to start talking about tangent lines. Tangent lines are perpendicular to the radius. So in example number 1, it's asking us to find this length CA, which is the radius, and it gives us this tangent line AB. So that means that AB and CA are perpendicular, which gives us this nice right triangle. So since we have a right triangle and we have 2 of the sides, we can use Pythagorean theorem. So r squared plus 4 squared equals 5 squared equals 5 squared. So r squared plus 16 equals 25. Subtract 16. And then take the square root, so r is equal to 3. So the length of CA here is 3. The second statement, tangent lines are equal to each other when they meet at a point outside the circle. So in example number 2, BA and DA meet at point A outside of the circle. If you were to draw in a line CD or CB, those would make 90-degree angles there. So since these 2 lines, AB and AD, are both tangent and they meet outside, they are equal to each other. So that means that x is equal to 7. In our third example, we're going to do the same thing. AD and AB are equal to each other, so we're going to set these 2 expressions equal to each other. So 5x minus 8 equals 2x plus 7. And then we're going to solve by subtracting 2x and adding 8. So I get 3x equals to 15, divide by 3, and x is equal to 5. So x is equal to 5 for this one. The second thing we're going to talk about is the radius and the diameter. So the radius is half the length of the diameter. So in this picture, they give us our radius, and it is 9. So we would double that in order to find the diameter. So I'm just going to draw a different diameter on here and label it 18. The third thing we're going to talk about is central and inscribed angles. So central angles have a vertex at the center of the circle, and then the arc measure is the same, so they're equal. Inscribed angles have a vertex on the circle, and then it's half the arc measure. So let's look at example number 1. They give us a central angle here of 123, and it's asking for this arc measure right here. So this arc measure is also 123. It's the same because it's a central angle. For example number 2, they give us a couple different central angles, but they're actually asking us for an arc measure, CFD. So CFD. They're asking us for that entire arc measure. So we're going to have to use our central angles here to help us out. So I know that FB is 135. And I know that ED is 81. So what I'm going to do is switch colors. So I know that FC is a diameter, which represents half of the circle, so it's 180 degrees. So I'm going to take 180 degrees and subtract the 135 of BF, and I'm going to get 45. So this arc in here is 45, CB. And I can see right here, CB and FE are vertical angles, so 45, which makes FE 45. So now I can add all of those together. I can add, I'm going to add from C to F, I know is 180, plus the 45 F to E, plus the 81, which is E to D. So I get 306. So the measure of the arc, CFD, is 306 degrees. For the inscribed angle, the vertex is on the circle, it's not in the center, and this angle in here is half of the arc that it opens up to. So this arc is 80, so this angle is going to be 40. So that angle is 40. In example number 2, we've got a little bit more going on. This angle right here is opening up to this arc FP. So FP is going to be twice this measure of FEP. So FEP is 35, so the arc FP is going to be 70. And then I know that FD is a diameter, so that's 180 degrees. So I know from here to here is 180. So I can say 180 and subtract this 70 that I found, and we get 110. So I know that the measure of the arc, PD, is 110.